in the test track.
We're at Algonquin Applied Research Day with Mark Eddey. Mark, can you tell us about your project?
Well, this is the second year that we've been developing a wind turbine. It's basically designed to be rapidly deployable and set up in, let's say, unimproved areas. Basically anywhere that remote power is required. Systems such as wind turbines or solar arrays are used to augment the power from generators.
How long have you been working on this project for, and what was the impetus? What was the starting point? What was the driver?
I've always wanted to build a wind turbine, and last year we were approached by Algonquin because they actually had a last-minute hole available in their group projects. A company had to back out. We've had about 7 months from the beginning of the project to today, so we haven't had an opportunity to do our final testing. We've been able to do virtual testing in some CAD software, so computer-aided design. So the entire product was originally designed in a software package, and then the students took that information and reworked it to what we have here. And that software allows us to do actual simulation or analysis of stress loads on the tower. And also we were able to simulate the loading of the airfoils to see how much power we could pull from the air and translate into electricity.
And what are the results looking like so far?
Well, our design goal is to be able to generate 3,000 watts of power in a moderate wind of about 40 kilometers an hour. And that would have the wind turbine blades spinning at about 120 revolutions per minute, as opposed to other wind turbines of about the same size where they spin at about 500 revolutions per minute. Regular complaints about wind turbines making a kind of a background noise. So the slower we can have the rotor blades turning, the less of that background noise will be generated.
And final question, how has the experience been working with the students?
Yeah, it's been awesome. I think what's good for the students and what's also good for me in industry is that I'm able to mentor them, teach them things that the professors couldn't teach them, because it's what I do in business is sort of the latest in prototyping and sort of product to market. So the students get to pick up on some of that. And what I get is a fresh insight into how to solve a problem. But I think it's a win-win for both. I'm always asking them, if they're happy with how the project is progressing. They give their input. If I feel that they're straying in the design, I will kind of gently nudge them into a direction from my past history that I believe will work better. They understand, they make the changes, and they get a feel for what it's going to be like to work in a real-world environment as a group, first of all, because normally they're working solo, and secondly, working with industry partners, ordering material, sourcing materials, dealing with unforeseen deadlines or product delays, all kinds of things. So it works out well.